Okay. We have already learned we have already learned about IP addresses and why IP addresses are needed, because people cannot remember people cannot remember numbers, but we can remember the names, but computers can remember the numbers. That is what we have learned about the IP address. And so also in the other class, in the paper class, we have just learned about how this layers, different layers work. So what is this 7-layer architecture we call ISO, OSI, International Standardization Organization, or International Organization for Standardization, then OSI, Open System Interconnect Model, and how that reference model divide network into pieces. We just discussed about that too. And now you have some idea about this IP addresses and which layer it works. Basically, if I remember the layers, like lowest layer in the TCP IP model, or this ISO OSI model is your logical LLC, or this LLC, or you can say physical layer basically. So let's think that is the bottom layer. There you can see the wires, and also bits are working there. Then just above that there is the logical this next layer, like that is data link layer. There most of these switches are working in the data link layer, and you have something called MAC address in that layer. If you go to your command prompt, cmd in Windows, and if you type ipconfig, so this is what I get as my IP configuration. My IP version 4 address is 192.168.0.130, and my subnet mask is this. This is how I think you can remember how we use subnet mask to identify the network. When you mask your IP address with the subnet mask IP using AND operation, then the network IP can be discovered. You have to write it in binary and then end it. Then default gateway is the route address, right? We can see these are the details. And in addition to that, so we can see MAC address of this. Let's use ARP command. ARP, ARP minus A. And can you see that? So this is the IP address, and this is the physical address. Physical address means MAC address. So any computer or device having IP address will also get a MAC address which is unchangeable. That is, so theoretically unchangeable, but there are ways of changing it. Theoretically unchangeable means physically that is there for that interface. But logically we can assign any IP address to that. For an example, my computer, I can connect this to even that now I have connected to the Wi-Fi, but I can connect this to my mobile phone using a mobile hotspot. Then my IP address will change, because it will take the IP address of particular network. The mobile phone, if I put hotspot, that is a separate network using data, and this computer will take IP address of that. But same time, so even though I take that IP address, my physical address remain unchanged. Here, the 0.1, this is router's physical address, we call MAC address. How many bits are there in physical address, MAC address? How many bits are there in a physical address or MAC address? Count and tell me. You can see here, just count it. Yes.
12.
12. A hexadecimal digit has how many bits? This is hexadecimal, right? Can you see? 12 hexadecimal digit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hexadecimal digit. I'm asking how many bits? One hexadecimal digit. How many bits are there?
4,
For
sir.
one hexadecimal digit.
4 bits, sir. 4 bits.
4 bits. Right. Then totally how many bits? Yes, totally. Totally how many pixels? Here 12 hexadecimal digits. One hexadecimal digit to get 4 bits. Then 12 into 4 is hello. Just simple multiplication.
Sir,
12 into 4 is
48, sir.
48. 48 bits are there. 48 bits are there in physical address. In logical address, IP address, how many bits? Version 4. IP address version 4, how many bits are there?
32.
32 bits? Yeah, version 4, yes. So version 6, version 4, 32 bits. But here in physical address,
So I couldn't understand.
no. Physical address means this one. Physical address has 48 bits. Can you understand that?
Okay, sir. Yes, sir.
Then logical address is this IP address.
Okay, sir.
Understood that?
Yes, sir.
Okay, then then there's another address, no, IP version 6 address.
Yes, sir.
That has how many bits?
So I really forgot, sir.
You can see IP version 6 address here. Then you can. You need to know this, right? These are practically.
Okay, sir.
Just count and tell me.
So 30, sir.
Yes,
So 30.
30. This is again hexadecimal. Count the
Okay,
number
sir.
of bit first. So each will get 4. But here why this is like why there is 3, because when there's 0 you can omit that. But
Okay.
4 in here 4. How many places? 4. 1, 2, 3, 4, 5, 6, 7, 8. 4 into 8 is 4 into 8 is 32.
32.
32 hexadecimal bits. Then one hexadecimal bit will get 4
4.
binary bits, right? Then 32 into 4 is
128.
128. Okay, remember that IP version 6 has 1 to 8 bit address. IP version
Okay.
6 has 1 to 8 bit address. Understood?
Yes, sir.
IP version 4, 1 to 8 bit. And IP version 6, IP version 4, 32 bit. Physical address will get 48 bits. Physical address is also written. These formats you need to remember, right? So IP
Okay, sir.
version 6 format, IP version 4 format, this is physical address format. Physical address is basically not changing. Each and every physical interface, like in network interface, NIC, and or router interface, switch interface, will get a physical address. So what is the physical address of this computer? You can see that as well. Actually, it is kind of a risky thing to show the physical addresses, because you are like, this is unique, no? The physical, by using the physical address, only the computer is identified, because this is basically unique, right? This physical address is unique, and each and every component will get a unique physical address. Okay. Right. You can also remember this command. You can also type ARP -A in your computer to discover the address. This ARP means address resolution protocol. Right. So let's use a document. ARP means address resolution protocol. Actually, that will translate physical to logical address and logical to physical address. Please remember these things. So these are the previously we have learned. IPv4 is like address having 32 bits, and IP version 6 address will get 128 bits. Then physical or media access control address will get 48 bits. Also remember their formats too, right? This is, and the commands to get that is basically, this is the format for physical address. And this is IP version 6 address. End in 0 can be omitted. That's why this is like lead in 0 can be omitted. That's why sometimes you can see 3 bits, but normally there are 4 bits. I just added like some bits to the end, right? This is not actually the thing that you saw. And IP version 4 address is easy, that we have done already. Okay, please remember these things with the examples. This is 48 bits, right? 48 bits. Oh, sorry. 48 bits. So physical address is basically not changed. This is called, these are logical addresses. Logical address can change. IP version 6 is also a physical logical address, so it can also change. But physical addresses will not change. Right? That is used to identify the things uniquely. Okay, finish writing.
So no, sir.
Then IP address is the logical, the commands. So what are the commands to identify the IP address? In command prompt, ipconfig to see the IP address details, and ARP minus A to see the physical and logical address conversions and mapping. Physical and logical address conversion and mapping. So you have to use ARP minus A command. Let's use some other color for the command. Otherwise, like you confuse with that. ipconfig is one command. ARP minus A is another command. So these two commands can be used to identify the physical and logical addresses of your computer. This also asked in the examination. Some papers, this also asked, right?
Okay, sir.
Okay. Then let's move to the slides again. Right. Then IP works in the network layer, physical address work in the hardware layer or data link layer, data link layer. Then network layer, layer 2, that is where the IP addresses work. And layer 1 is where the wires and bits are working. Transport layer, actually the TCP, transmission control protocol works. That is ensuring reliable delivery. It is like a protocol with a delivery report. It ensures reliable delivery, right? So that is IP, and that is reliable delivery is ensured by this TCP. So can you tell me what is unreliable or this connectionless protocol working in this layer? So this is connection-oriented protocol, no? TCP is a connection-oriented protocol, work with IP in the transport layer. So what is the connectionless protocol work in the transport layer? Yes?
So UTP.
UTP, yes. User data driven protocol, that is connection less secure, and it's not having any delivery like delivery notice mechanism, right? That is connection less protocol. It's not connection oriented, it's connection. Okay. You can see a snapshot of this here. Application layer use data, transport layer use UDP or TCP, and then the network layer, and finally you can see the MAC addresses in physical data link layer. That is the idea, right? So this picture sometimes they might use kind of not the same. So these symbols, please you can remember them. So here this is switch symbol. Switch is working in layer 2. Layer 3 routers are working. And you can see this is application UDP header. So don't think much about these things. This will be asked in the degree level, not in your level. But this is how a packet is formed. A single packet is actually having different headers. And let's see that how the packets are sent. So this is a packet. Packet is basically a small data chunk, but it has many things. It has MAC related IP address, sender's IP, receiver's IP, headers, etc. Don't think much about this packet delivery. Anyway, just understand these packets are sent to the network. That's all. So this packet delivery is not really required in your level. They will not ask in detail. Right. Why IP addresses? Because that is the logical address, which is changeable. Time to time, we need to join a different network. Therefore, MAC address is unchangeable, but the IP address is changeable. That is why we have IP address. And also, a computer need a number. Right. All classes of IP address we have learned. So this is actually the format of the IP header. You can see there are a lot of things, but just forget about that. Just think about. So IP header is basically a part of frame. Frame means something sent in the next level. Packet is sent in the network level. Frames are sending These packets will be converted to frames in the data link layer and sent, right? No, just get an idea. Don't try to buy hard these things. I know these things you cannot understand. Doesn't matter, right? Because that is not the aim of this. Just know the terms. Okay, then IP address can be dynamically assigned, or it can be assigned like manually assigned. Dynamically assigned, we call dynamic host configuration protocol. So when you join a Wi-Fi network, are you giving IP address to your computer, or it's automatically taken? Normally, when you connect a Wi-Fi network, how the address is taken? Is it automatic, or normally what will happen?
Automatic.
You're going to type IP address to your computer manually.
Automatic.
It is automatic, right? It is automatic. Therefore, this protocol, please remember the protocol which is giving this IP address automatically. That protocol is called DHCP. So what is DNS? DNS protocol, domain name system. So what is that? What is this?
Sir, DMS. Sir.
Sorry,
Sir, repeat the question, please.
can you repeat?
Sir, repeat the question, please, sir.
Okay. What is DHCP? First tell me what is DHCP. Meaning of DHCP. Meaning of DHCP. Dynamic. Come on, these things we have discussed already in the paper class also.
So couldn't remember, sir.
But what can I do for that? Right? You need to remember these things, right?
Remember.
Otherwise,
Okay.
it's very difficult for your examination. DHCP, Dynamic Host Configuration Protocol. IP.
Okay, sir.
IP.
Sir, meaning of IP, sir.
Yeah. Okay. Let's do that. Otherwise, like find the meanings, right? Find these meanings.
Okay.
I'll give you a small activity. So you can browse internet,
Okay.
doesn't matter, but only this time, next time, what you need to do, you need to remember these things. IP.
Okay, sir.
So these are some protocols. I'll insert a table. Protocol, meaning, usage, and layer. Okay, I'll write one thing. IP, Internet Protocol, assigns IP address and works in network layer. So it is layer number 3. In TCP, in this OSI model, ISO-OSI model. Then you need to know TCP, UDP, that's why it takes time, right? Normally, like I thought that you know the theory part and I'm proceeding to the calculations. When I'm like moving to the calculations, I understand that you're not good in theory. Then I have to come back and explain the theory. That is bit difficult because like then it will take regular time to finish this task. Doesn't matter, I can do that, right? But don't think that once you fill a tute or once you go a class or once you learn this in a book or somewhere, don't think that you will know that. Don't come to that prejudgment. Everything is linked. Everything is linked and it has a meaning. So if you like when you remember that, we cannot. So in Sri Lanka, you know, a lot of students think like this. When you remember something, you think you know it. Remember and knowing is two things. if you remember accelerate, brake, brake and clutch and the steering wheel, that does not mean you can drive, right? So
Okay,
here in computing, if you know these things, if you remember these things, that does not mean that you know networking, right? You need to know networking in order to answer the paper. But in the paper, they expect this your knowledge in actually your skills, especially they expect that in understandable level. Sometimes you try to buy hard the chapter, thinking that this is a theory chapter. So, DNS, okay, I'll give the main thing: HTTP, FTP. I think your mic is a bit noisy. You have to turn off that. Okay, FTP, SSH. Okay, that's enough for this chapter. That's enough. I think you need to know at least these things. You need to know. Otherwise, like it's a big trouble. These protocols are, generally protocols are set of rules in network communication, right? I think you know that protocol, a set of rules in network communication. Rules used in network communication. So these are some common protocols that we use in everyday life. So just find the meaning very quickly. I'll give you 10 minutes, find the meaning. And so don't write big notes, just find the meaning and then just put the layer and just purpose. Don't write big paragraphs for the purpose, just the idea. I'll give you 10 minutes, do it quickly. TCP for transmission control protocol,
control
right?
protocol.
So which layer it works?
I didn't see the layers. I saw the usages.
So it's working transport layer, right? Layer 4. So what is the duty? It's ensuring reliable delivery, right? Transmission control protocol. Ensuring reliable delivery of the packet. It is connection-oriented protocol. It makes the connection. So data connection-oriented protocol. It works in transport layer. UDP is connectionless protocol. It's fast delivery is the aim. Goal is the fast delivery. User data driven protocol. User data driven protocol. Its aim is fast delivery of packets. It's connectionless and less secure, but good in video streaming and also work in the transport layer. DNS, domain name system. The task is converting the domain name to IP and IP to domain name. So that is working. So it is basically there are specific servers or special servers for these domain name systems, DNS. Why? Because everywhere we cannot remember the IP addresses. We have to access through the domain. Therefore, the IP to domain and domain to IP conversion is must. HTTP, again, another one which works in the application layer. So that is ensuring the application layer web transport, hypertext transfer protocol, transporting web in the application layer. FTP, file transfer protocol, again work in the application layer, transporting files. SSH, secure shell, so to make a secure connection between two parties. So work in session and this application about the session. Then to make there is a SSH we call handshake So secure connection is made over that. SMTP, simple mail transfer protocol, that is work in email, basically for email transfers between the servers. SMTP is used. SNMP, SNMP. Hello.
It's a simple network management protocol.
Yeah, simple network management protocol. So basic task is the network management, and the below layer, so it is ICMP, Internet Configuration Message Protocol. So basically, when pin request and all the connection testing can be done, communication and connection testing can be done using ICMP when internet is there. POP, Post Office Protocol. POP3 is Post Office Protocol version 3. POLA, email. So POP is basically, so what's the difference between POP and IMAP? Internet Mail Access Protocol is only accessing the email. POP is downloading the email and erasing from the server. Right? POP is just downloading the mail and erasing that from the server. After that, the email is not there in the server. So it will be downloaded to your inbox. But IMAP is just accessing without downloading. It's downloading, but it keeps a copy or in the server too. Both are for receiving emails. RIP, Router Information Protocol. Routers communicate with each other router using the RIP. It is not rest of peace, it is it's not rest in peace, it is Router Information Protocol. ARP, Address Resolution Protocol, converting basically the MAC address to IP, IP to MAC conversion. The physical to logical address conversion is there in this layer. And then the HTTPS, Hypertext Transfer Protocol, secure version, which is encrypted version of, it is also application layer, encrypted version of hypertext is transported in HTTPS. So these are some main protocols that you need to aware before we begin the lesson, right? Now you have proper idea. Don't ask me what is this, I cannot remember, because these things are really necessary. So go through these things, study these things, because in the examination, these things will be tested. Not just that, for your life, to understand this, you need that. Okay, so the network prefix. So basically, before 1993, we used class-based routing. That is what we have learned last day. But now we are using classless. Like class-based routing is like no more in the use. The reason is basically now we are more flexible having classless inter-domain routing. It is more flexible way of implementing this routing. So that is now there. Okay, classless inter-domain routing. Then okay, so here IP address is converted to a binary number. You can see this. When IP address is converted to a binary number like this, so it's easy to do the masking thing. So the first octet, second octet, we call first octet or first byte, second byte, third byte, or we can call it first octet, second octet, third octet, and fourth octet. So this is, we call dotted decimal notation. Actually, we display this IP address in decimal number, but basically inside the IP address in the binary number. We learned that. And so when there's an IP address given, so can you see this IP address? This is related to this domain, right? So then actually it is class B IP. You can see the 2 octets are allocated for the network. The second set of octets are, the next 2 octets are for the hosts. Here, these 2 for the network and these 2 for the host. Therefore, the subnet mask, you can say 255.255.0.0, because when you mask with 255 means all ones, no? We did that last day. 255 is all ones, 1, 1, 1, 1, 1, 1, 1, 1. When you end something with 1, so you'll get the same thing. Here, 128. So let's say 128 is 1, 0, 0, 0, 0, 0, 0, 0. When you end this bit by bit, end it. So 1 and 1 is 1. 0 and 1, 0, 0, then 0, 0, 0, 0. All zeros will come because all are zeros. Then it is still 128. That means if you end something, this number, when you end with 255, you will get the same number. This number, when you end with 255, you'll get the same number. Therefore, we actually the network IP of this is 192.128.143.0.0 because this is one and with 0. Then the network address is this. So what is the broadcast address? What is the broadcast address of the same? Network address is 192.128.143.0.0. Broadcast address is 128. Yes, 143.
143.
Then broadcast address is the last IP that you can assign to the same network. That is 255.255 is the broadcast IP. That is not given here. That's why I am writing, right? This is called broadcast. Broadcast IP is this. And network IP is this. In between that, how many hosts are there? What is the first valid host of this? First valid host, IP of the first valid. This will be asked in the examination. We discussed this, right? 128.143.
0.
Yeah,
1.
0, 1. What is the last valid IP? Last valid host? 128.
143. 255. 25.
25.
5.
255 is broadcast IP. You cannot do that. Host 254 is the last valid host. The first valid host is this. The last valid host is this. How many computers are there? 2 to the power 16 minus 2. 2 to the power 16. Because 2 to the power 16 is including this IP and this IP. But you have to subtract the 0th IP and the last IP, broadcast IP. Then you'll get the number of computers that can be put in one network. So one network, you can put that number of 2 to the power 16. That means I think 65,536 minus 2. So 65,534 computers can be placed in one network. So this is the CIDR notation. So we call this class A, class B, no? But without calling class B, we can call 128.143.137.144. That is the IP address of this /16. What you are telling here, 16-bit is allocated. Yes, 16 bits are allocated for the network. That is what it says. 16-bit, 8 bits, and the next 8 bits altogether. 16 bits for the network. That is the CIDR notation. I hope you can understand CIDR notation now. Let's see one more example for today, and next day we can discuss the remaining stuff. All right. So these are the private address ranges, right? So I couldn't tell this. These are the address ranges that we are normally assigning as private IP addresses. So if it is class A, we are assigning this range. If it is class B, we are assigning this range. If it is class C, we are assigning this. That's why your computer will get address like 192.168. That is basically these address ranges are reserved for the experimental or use, and basically these addresses are assigned for the private networks. Right? We learn about this. Loopback IP address is 127. If you have 127 address, I said in the class-based routing, 127 address is assigned to the same computer. Loopback. I can call my computer, or I can, if I PING localhost. It's not showing the IP address, but I can do PING 127.0.0.1. This is my own computer. So that is called loopback IP. Right. Then you have subnetting pass. Okay, now we have almost done. Theory part is also done. Yes, we can discuss about this next. It needs some more time. Okay, I'll discuss in the next session. Maybe tomorrow we can have another session if you're free. Or Friday morning we can have another session. So whatever preferred days, please let me know. I'll then do the session. Okay?
Okay. Okay.